For this parallelogram, I'm going to let B equal the base, S is going to equal the slant height. So to find a perimeter, just add up the length of the sides. S plus B plus S plus B. So my formula is P equals 2B plus 2S, or twice the base plus twice the slant height. To find the area of the shaded parallelogram, just multiply the base of the parallelogram by its height. So the formula is A equals B times H. Finding the perimeter of a trapezoid could not be any easier. All you need to do is add up the lengths of all four sides. S1 plus S2 plus S3 plus S4. And here's the formula. To find the area of the shaded trapezoid, let B1 represent the first base, B2 is going to be the second base of the trapezoid, and H is going to be its height. The formula is A equals 1/2 times the quantity B1 plus B2 all times H. Now most trapezoids you would encounter are something like this. You have a base over here and a base down here. But in calculus, trapezoids tend to be flipped on their sides. So we need to worry about area formulas based on the heights. So let's do that next. I'm going to define H1 to be the first height, H2 is going to be the second height, and B is going to be the base of the trapezoid. The area formula is A equals 1/2 times the quantity H1 plus H2 all times B. And here's our last bit of information we need to know about quadrilaterals. The sum of the measures of the interior angles of any quadrilateral is 360 degrees. Here's a generic quadrilateral. I'm going to define my interior angles as alpha, beta, gamma, and delta. When you add them all up, you will always get 360 degrees. Let R equal the radius of a circle. D equals the diameter of a circle. It's twice the radius, so its formula is D equals 2R. The perimeter of a circle is actually known as the circumference. Its formula is C equals 2 pi times R, or C equals pi times D. The area formula for the shaded circle is A equals pi times the square of the radius, or simply pi r squared. By the way, pi is just the number of diameters that would fit on the circumference of a circle. So you have 3 of them and a little bit left over. So now let's take a look at that in detail. So here's pi. It's approximately equal to 3.14. And now let's take a look at a few other decimal places. Did you get all that? Alright, good. It's worth memorizing the typical approximation for pi, which are 22 divided by 7 and 3.14. For this cube, I'm going to let S be one of the sides, D is going to be the diagonal on one of the faces. Its formula is going to be D equals S times the square root of 2. Here's an example of a cube. The diagonal of a face of a cube can be seen right here. Given side S, I'm now going to let capital D be the diagonal of the entire cube. Its formula is going to be D equals S times the square root of 3. Here's another example of the diagonal of a cube. It's this darker line you see right there. given side S again, the formula for the surface area of a cube is SA equals 6 times S squared. To visually see this formula for surface area of a cube, first let's consider one face. Its area is going to be side times side, S squared. But we have 6 faces to a cube, so we can visually see it like this. Just take this out of here. And say we have 1, 2, 3, 4, 5, 6 faces. That's where we get our formula, 6S squared. The volume form is going to be V equals S cubed. Here's an example of a rectangular parallelepiped, or a rectangular box, or simply a box. I'm going to let D represent its diagonal, L is going to be the length, W is going to be the width of the box, and H is its height. With this in mind, the formula for the diagonal of the box is D equals the square root of the quantity L squared plus W squared plus H squared. Visually, the diagonal of the box will be something like this. It goes from one end to the other over here. The formula for the surface area of a box is SA equals 2 times the quantity LW plus WH plus LH. Here's another way of seeing the surface area of a box. We'll just take this out of here, and you can see it right here. So our formula helps us find the area of all these little rectangles. To find the volume of a box, just multiply the dimensions together. Length times width times height. So the formula is V equals L times W times H. Here's an example of a prism. Specifically, this is a triangular base prism because the base is in the shape of a triangle. Now, let's make this a square base prism. Next, let's change it into a pentagonal base prism. As you can see, the base is in the shape of a pentagon. Okay, it's time to morph it into a hexagonal base prism. Finally, I'm going to transform it into an octagonal base prism. Hey, that kind of looks like a stop sign, doesn't it? I'm going to define A to be the area of the base. H is going to be its height. The volume formula for any prism is V equals A times H, or area of the base times the height.